marks. You want to try to get full marks on sketching, right? Okay, so sketch a kite labeling two properties. You should have on your study sheet a kite, and it should have two triangles that are basically stacked, and one should be longer than the other, because otherwise you're talking a rhombus, right? So if I graph this, then if I do this and this, if you have that, you would get 1 mark for sure. That's property number 1. Property number 2, if you want to talk about the diagonals, if you have a 90 appearing there, that is a second property. That would get you another mark. This is where it gets tricky. If let's say this is another one, a different student answered this way. So saying that, there's two pairs of side lengths that are the same, and then we're talking diagonal. This one here is cut in half, but you can't put 1 and 1 because then you're saying these are the same, which is not necessarily true. So you need to do like a 3-line. You indicate that these two are the same, but it's no relation to the outside. Okay, so you got to make sure you get that right. Another thing that you can talk about is that this angle is the same as that. Another property, you can, I think I covered them all. That the diagonals meet at a 90 but the shorter one is bisected. Right here you have two properties right here. And this last one. So just make sure you have two properties labeled correctly and you get 2 marks for that one. Okay? Just make sure you're honest. There's no point in trying to inflate your mark there. The second question is a rhombus, right? Label a rhombus. So a rhombus is basically a slanted square. So option number 1 is saying that all 4 sides are the same in length. Maybe you want to talk about the fact that this angle and this angle is the same, and so are these two. This would give you 2 marks right there. If you want to have another one, and you want to talk about the fact that there are 2 pairs of parallel sides, that would be a rhombus. That's property number 1. And let's say you want to talk about the diagonals. The diagonals cut each other, they bisect each other like that. What else do we know about the diagonals? It's been a while, right? Thursday. They are, yeah. How many degrees? Almost 90. Is that what you meant to say? Okay. Yeah, there should be a box there that tells me that it's 90. So if you put the box there, I won't know that you thought it was 80. You get the mark. So that is there. Perfect. So any combination of any 2 will get you 2 marks there. The problem is, this is the problem. And please don't just remember it, right? So if you're saying all 4 sides are the same, and then you're like, hey, this is cut in half, that's wrong, right? Because now you're making association with the outside. Just make sure, right? These 2 are the same, and these 2 stretches are the same, right? So make sure you don't make an association with the outside, okay? There we go. And number 3, sketch an isosceles trapezoid. Two properties that are true. So trapezoid is basically a triangle, a big triangle where the top has been cut off, right? That's a trapezoid. So we know that these 2 sides are the same if it's isosceles. We know that this angle is going to be the same as that angle, and that these 2 angles will be the same. We also know that the top and the bottom run parallel to each other. They will never meet. And this is the one I didn't talk about, which I will ask you to add in a bit. We also know that this diagonal is the same as that diagonal. So the best way to talk about that would be saying that PR, like from P to R, is the same thing as from Q to S or something like that. Because if you put a mark in here, like it doesn't, it could mean that where they cut each other, right? So that's 2 marks right there. 4. So 2, 2, and 2 so far. Okay, let me just fold this here. Question 4. You know that this is 25, therefore this is going to be 25 as well. Like if these two sides are the same, then the angles across from them will be the same. As soon as, can I say this? If you have an isosceles triangle and you know one angle, you can actually find all of them immediately. You just have to know where to put them. So this angle right there is going to be 180 minus 25 minus 25. This adds up to 50, right? So 180 minus 50 gives you 130, which tells you this triangle is obtuse. You get a mark for that. And because two sides or two angles are the same, it's, isosceles. It's isosceles. So you get a mark for that word. Doesn't matter which order. If you have isosceles, obtuse, it doesn't matter. But you've classified it effectively. So that's 4A. You get 2 marks. 4B, you can tell that all 3 sides have a different measure. So that's scalene. Scalene, so if that shows up, you get 1 mark. Obtuse, is it obtuse? It definitely looks obtuse. If the sides are all given to you, I would like you to check. Because this is a side triangle, right? So the one that's across the longest side, this angle can potentially be obtuse. So we use cosine of angle A. All you have to do is this. Just do the top, right? You will make sure you subtract the side across the angle you're interested in. And then it's the other 2 sides squared and added. And we're going to check if this is negative. So 5 squared plus 4 squared minus 8 squared, that's negative 23 at the top. And that tells you that it's obtuse. You don't have to actually solve for the angle. That's going to be obtuse. So you get a mark for obtuse and a mark for scalene there. If no sides had been given, then you just go by the diagram, if it's obvious, right? 5, which is the bonus, let's do that first. We're going to learn more about that today. So after today, you should be able to do it. So here's the bonus. So basically, if you cut it here, you know this is 8 feet. I will subtract, I will go 18 minus 12 gets you 6, right? So that means that this is 6 feet. If you subtract these two, you're left with what this is because you're taking away the 12. This is my unknown, which is the height of the trapezoid, which is one of my legs, right? And so you got to go hypotenuse squared minus the other leg squared. So x is going to be square root of 64 minus 36 is 28. So square root of 28 is 5.29. And we are in feet. So if you have that, you get a bonus mark. Plus 1. You can go plus 1 if you want. And now the true and false. So here we go. Just 1 mark each. A rectangle has diagonals that are congruent. What do you think? The answer is true. Like if you think about it, if this is a rectangle, right, both diagonals are going to be exactly the same in length. So 4A is true. Sorry, 6A. 6B, diagonals in a kite bisect each other, and that is false. They don't bisect each other, only Only the short one is bisected. This one isn't, so that one would be a false. C. I'm going to do C right here. A parallelogram can also be a square. The answer is yes. And why is that? Well, think of a square and let's see if it meets the parallelogram criteria. Does it have two pairs of parallel sides? Check, right? Does it have two pairs of congruent angles? Yeah, one pair, check, right? So it actually meets all of the criteria. So you're good. D, all squares are parallelograms. That is false. Oh, sorry. All squares are parallelograms. That is a true statement. All squares would meet the criteria of a parallelogram. I got ahead of myself there. E, a rhombus has four congruent angles, and that is false. A rhombus only has, right, two pairs of congruent angles. Not all four are congruent. So you get 5 marks for question 6. So you got it right or you don't. Okay. So again, for 6, it's true, false, true, true, false. True, false, true, true, false. So make that out of 5. 6 is out of 5. Let's go backwards here. 5 is a bonus, so you don't take marks off if you lose it. 4b is 2 marks. 4a is also 2 marks. So question 4 is out of 4. And then question 3, 2, and 1, they're each worth 2. So 2, 2, and 2. So that'll give us a total of 15. So name and last name, add it all up, and then go to page 190 in your booklets. Page 190 in your booklets, go to the bottom trapezoids there. Page 190. Okay. We continue our journey. Go to 190, okay? I want to add something to Isosceles Trapezoid. Just quick here. I will add to this list of properties that is specific to Isosceles Trapezoid and just say congruent diagonals. So there's congruent diagonals. So if you want to do this, (190). So if you want to just have an isosceles trapezoid and just make the diagonals like this, they're the same length. If you need this, page 190 and 191 is very important for you to have. Check out Thursday's video if you go to Google Classroom. You can watch it at a faster speed, right? And pause it. So you just add this to page 190 at the bottom there before we continue. So if you're wondering, what are we adding? Just this part right here. And it's the diagonals here that are the same, guaranteed. So I would say there's going to be a significant amount on this stuff on the test. So try to somehow bring this over onto your study sheet. You will not be allowed to use pictures or notes or something like that. So it has to be your study sheet. Do a little bit of work, right? Doesn't take much. Alrighty, moving on to page 192 here. So if you missed everything else, if you're copying that, just go to Thursday's video, okay? Page 192, you have a bit of a tree here that tells you how shapes are related. You don't really need to worry about that. One thing that you can do is a square, right? The further down you go, the more specific you get. And so what I want you to highlight or underline at the bottom of 192 is when classifying a quadrilateral, be as specific as possible. So sometimes you'll look at a diagram, you'll be like, oh yeah, it's a parallelogram. But sometimes there's going to be enough information that you can actually say it's a rhombus, right? So for example, if I give you one of these, right? I say that this is 2 centimeters, 2 centimeters, 2 centimeters, 2 centimeters. You have to be very careful because I trick you sometimes, like I make them look different, but if you look carefully, look at these numbers. Parallelogram, it could be a parallelogram, but specifically enough, all 4 sides are the same, it's a rhombus, right? 4 congruent sides, right? So it does look slanted, but this is being specific, right? This is general. In this case, saying that it's a parallelogram would be a general statement, but you need to be as specific as possible. Okay. Got it? Look at markings, look at numbers, whatever I throw at you, be comfortable with that. And now we're going to do a little bit of math here. So let's go to 193. 193, okay? So some notation, nuances, and all of that kind of stuff. Nothing you can't handle. You should be able to handle this. Don't overthink it. Sometimes it's as easy as just looking at the diagram. Sometimes you're going to need to do some work. So page 193, they're asking you to find AC. So if they're finding AC, it's a side length, right? From A to C, we're going to call that X. Okay, I actually encourage you to do that. Then it's asking you to find angle A, which is up here, and angle B, which is angle B, which is up here. And then it's asking you what type of quadrilateral is ABCD. That's quite often what they're going to do, or what I'm going to do is I'm going to ask you to find a whole bunch of stuff, and then I'm going to ask you, okay, now classify it. So we're looking at this. The first thing that should ring a bell here is the fact that these two angles are the same. That is definitely an isosceles trapezoid. It's not just a trapezoid, it's an isosceles trapezoid. We only have two choices for trapezoid. It's the right trapezoid or the isosceles trapezoid, so they're very easy to distinguish, right? Because these two angles are the same, we also know that we can say that these two sides are the same, just like an isosceles triangle. So angle X is, not angle, side X is going to be 4 centimeters. There we go. That's it. Like no further work involved there. Then we're going to find angle A. How would you find angle A? If you go back to, can you go back to properties in 190? I did something to every single shape at the end. Go ahead, MJ. You could, but there's something easier than that. Let's go to 190. Sorry? 180. These two add up to 180. Do you remember that? You doing that on page 190? You're like, Mr. Durson, I wasn't even aware that I was here on Thursday. Okay? But I made you do this to every single quadrilateral, knowing that those two angles on the same side always add up to 180. I made you do that in your notes. I hope you did it. If not, maybe do it now. Okay, so we know that these two angles always on the same side, they're both on the left side of this trapezoid, they add up to 180. So to get angle A, always, folks, it's so easy. If you know one, you know the other. Take 60 away from 180. Angle A is 120 degrees. You're done. So a little bit of work needed there, but not a whole lot. Angle B, therefore, because it has a 60 down here as well, I wouldn't expect you to do this again. You just go ahead and say that B is also 120 because there's a 60 here. Okay, so I will just say here, same as angle A at the bottom. And there you have it. You're done there. So a little bit of math, and we'll do a bit more as we go along. Just need to know your properties. Find WX. WX is just a side length. It's this stretch right here. Let's call that X. Okay? I encourage you to do that. It's much easier to work with. I want you to go and find this angle. Put your pencil where this angle is supposed to be. Angle XYZ. Take a second or two, look at your diagram, and just put your pencil right where it's supposed to be. And then we'll call it Y. Okay? So I read it exactly the same way it's here. X, then I'm going to connect to Y, and then I'm going to connect to Z. So it's actually asking for this whole thing here. and we're going to call this y. Okay, that's the angle. So now it's much easier. It's like, hey, just find y. Angle y is going to be equal to, no math here. We know that these two are the same if it's a kite, right? It's 101 degrees. And I will just make this little diagram here. We know that these two are congruent, right? That's why we were able to state this. It's a kite, sorry, let's write that down as well. It's a kite, and these two angles are always the same, no matter what. Okay? Right, next. Go ahead and find this angle and call it lowercase m. Then find this angle, call it lowercase n. Where are those angles located on your diagram? There's only two left, right? Which one is which? Go ahead and do it so you know. If I do this to you on a test, you will know how to find it. WXY, I just read it, WXY. It's this one right here. And this is lowercase m. YZW, you just read it, YZW, that's this one right here. And that one is called lowercase n. Okay, it's on page 193. And so it's asking you this. Just read carefully. None of these is a lot of work. Most of them are just straightforward. What is the sum of m and n? So in other words, if you were to add these up, what would it be? Okay. What do all four angles add up to in a quadrilateral every single time? 360? Do you remember that? I hope you all remember that. That's always the case. Triangles 180, four-sided 360. So I'm going to go 360 minus this 101 here minus the other 101 that is on the other side. These both are 101. And you get 158 degrees. This is the sum of angle M and angle N. Okay? Sorry, I was off track there. There we go. Does this make sense that these two angles would have to add up to 158? Because if you take away the two that you know, then these two have to add up to 158. We don't know what each of them is individually, but we do know 158. Okay. Would we be able to figure it out using sine law and cosine law? Probably, but we're not going to go there right now. Okay. I want you to add this question. Cut it off right here, the bottom of this. Okay. See, you ran out of space. 193. You're good. Bottom of 193, you should have enough. Okay, copy this one. It's an isosceles trapezoid. This is 5 centimeters. It's the same. 6 centimeters for the top, 10 centimeters for the bottom. And I'm going to do this. A, calculate the height. Calculate the height of the trapezoid. That's going to be our first step here. Let me just zoom in a bit. Calculate the height of the trapezoid. If you have a different color, every time you have to do one of these, you have to do the following step. Identify where the height would be. Watch this. I'm going to go to the end of the top here and go straight down. And know that that would be a 90. That would be the height of the trapezoid. But it could also be, if you just follow along to the other end, you make a dot there and go down like this. You could use either one of them, and there's two triangles, as you can tell. Two right triangles formed, and they're identical. Okay, so which one of these two would you like to use? The answer is it doesn't matter. If this is 5 centimeters and these two sides are the same, then this is also 5 centimeters. Cut it out. Get the 90 in there. We know this is 5 centimeters. This is what we want to find. You could have called it X if you want. And how would we find this bottom piece here? That's where it gets trickier, maybe a little bit trickier. Let's look up here what I'm going to do. I'm going to take the 10. I'm going to take the 10. I'm going to subtract the 6. So if I take 10 and I subtract that piece here that is 6, I need to divide that remainder in half. Because if you subtract them, you get what this and this would be together. You need to divide it by 2 to just get this one side here. Okay, so that would be 4 divided by 2, which is 2, and that's what goes in there, 2 centimeters. Maybe I will do this. Highlight this stretch and this stretch, and that's why I divided by 2. If there hadn't been this piece here, no need to divide by 2, right? You just subtract. But because you have both of them, you need to divide by 2. And now you have Pythagorean theorem. And some of you are like, wait a minute, Mr. Dirksen, I see sine law here. I see this pair. I wouldn't recommend it because you don't know the angle across the side you're interested in. I would use Pythagorean theorem. And by the way, this is a missing leg, right? So if you're missing one of the legs, it's taking the hypotenuse, subtracting the other leg from it. H is going to be square root. This is 25 and this is 4, so that'd be 21. This will for sure, something like this will show up on a test. Maybe not exactly the same way, but definitely these skills here. So if you want to have this on your study sheet, it certainly will not hurt you. You found the height of this trapezoid. B, calculate the area of the trapezoid. And I'm going to give you the formula for the area. Area of a trapezoid is taking the top, adding the bottom to it, multiplying that answer by the height, dividing all of that by 2. It looks scarier than what it actually is. Okay, so area would be the top, which is 6 centimeters. That's you. Taking the bottom, which is 10 centimeters. Make sure you put that in brackets. You multiply it by the height, which I just found, and you divide that whole answer by 2. And watch this. You need to do this in the brackets first, which is 16. I don't even need a calculator for that. then you go, right, once you figure out that this is 16, then you multiply and divide by 2, which gives you 36.64, and we are in centimeters. Area is always in squared units, right? That would be the area of this particular trapezoid. And we'll do one more, which you will copy. One second, I just need to double check here. Would be 41, okay. You're still awake? Way to go, guys. Aren't you happy you're in grade 12? You're happy about that, aren't you? That you're graduating? I would be. And you made it through COVID, which is something else, right? Calculate the height and area. So we'll just make it a 2-in-1 question right there, and then copy this down. This is a right trapezoid. Where this is 8 centimeters. The top is 14. The bottom is 20. I'm going to draw in your height already. The key is you want to do it so that you get your right triangle, right? So you go to the corner of the top and go down, right? You don't want to go anywhere. You want to go to, this doesn't make sense over here. So in this case, you'd go here. This is the height. And I will do this with you because I have more coming up. I actually added some questions there. So in this case, cut out that right triangle. Strongly recommend you do that. Introduce letters if you need to. This is my height. And in this case, to get that, do I need to divide by 2? No division here. So all you do is 20 minus 14. This is on page 194, right? So that's 6. So this chunk right here is 6 centimeters. It shouldn't be longer than your hypotenuse. So make sure you keep an eye on that. H squared, sorry. This is one of my legs again, because the hypotenuse is given. I need to take the hypotenuse and subtract the other leg from it. 64 minus 36, that's 28 again. There was 21 earlier, sorry. This is 28. Take the root of that, you get 5.29 centimeters. You're checking, right? Centimeters, meters, inches, whatever it is, you tack those on. This is your height. You're halfway there, over halfway, I would say. And then I will find the area. It's a trapezoid. Same formula for, you take the top, you add the bottom, put that in brackets. That gets multiplied by the height, and then divided by 2 at the end. You always divide at the end. Deal with what's happening up top. So 14 and 20, that's 34, times 5.29. Divide that by 2. That's 89.93. No rounding necessary. And in this case, it's centimeters again. Make sure you have a square, like a little 2 on top of its area. I will maybe highlight that, right? Now, copy that down, and then I will tell you what to work on for the rest of today's class. Maybe I'll write it down here, okay? No, sorry, I'm going to do the next page. Again, if you just practice, right, and you complete your study sheet, I think you have a pretty good go at this unit, right, to boost your mark. And go to 196 real quick. It's a blank page, completely blank. So go to 196, copy this. I want you to practice this on your own. Find height and area. There you go. Let's introduce inches here. Just copy that down. And then on this page, I want you to work on, you should be able to do quite a bit. So these two pages, keep in mind 196, all you have is this on there, right? And then page 199 to 200. And I need you to practice this, okay? Apply what we've learned today and perhaps what we've learned so far. I will come around and check to see if you're getting it. And there's one more thing. There's a typo, and I want you to make sure you're not wondering what happened. I'll tell you where the typo is. 195. You see that 24-degree angle there? That is supposed to be I thought I wrote it down. 1 second. 195. This angle right here is not 24. Give me 1 second here. It's not, otherwise it's 59 degrees. So scratch that, it's 59 degrees at this angle right here. That's on 195. Okay.